This video will go over the Chapter 9 review homework, starting with number 2. How can you find the center of a circle with a compass and a straight edge with patty paper and then with the right angled corner of a carpenter's square? So possible answers could be, with a compass and straight edge, you would draw two non-parallel chords and construct the perpendicular bisectors, the intersection perpendicular bisectors to the center of the circle. And this was the question we had on the quiz 1. 9.1 and 9.2. I think one of the versions of the quiz had an arc, another version just had 3 points. And if you had an arc that went through all those 3 points, how would you locate the center? And how it worked was you had to draw two non-parallel chords anywhere on the arc. Didn't really matter where they were, as long as they were non-parallel. And then you do your perpendicular bisector with a football, and you get a line, but you only know that the center is somewhere on that line. How do you know that? Because of conjecture 80. Perpendicular bisector of a chord conjecture says the perpendicular bisector of a chord passes through the center of the circle. So you know that somewhere on this is the center of the circle because of conjecture 80. So then I have to do another perpendicular bisector with my compass. And then where those two intersect is the center of the circle. Right? So that's because of conjecture 80. It's the center of the circle. And so this is going to represent an entire circle, right? So, okay. But what if you had, let's say, a circle here? And what about with patty paper? How would you do that? Well, you could fold the paper along a diameter so that the two semicircles coincide. Repeat with a different diameter, and the center is the intersection. In other words, if you have it on patty paper, you could fold it right down the center. And so you know then that the center point's somewhere on that diameter. Now, if you fold it the other way or some other way in half, then where those two diameters intersect, that would have to be the center. So you fold in half. This is with patty paper. It's with compass. Okay. With a right corner carpenter square, if you have a circle, what you can do is, if you have a right angle, then you put that somewhere on the circle and you'll make what's called an inscribed angle. And then you'll draw in a diameter, because you know that an inscribed angle that's 90 degrees, the endpoints are on the diameter of a circle, or they intercept an arc that's 180 degrees. Now, if you do that twice here, so if I do that twice, I draw in a diameter, then where those two intersect should be the center. Now, they're not, because I didn't do a very good job. So let me see if I can do that again here. I wonder if I can just use, can I use the end of this thing? No, it has no end. Okay. Let's see here. Maybe I can do it this way. Let's do it like this. I'm going to try to eyeball a 90-degree angle here. How'd I do? Oh, pretty good. Right, so I have looks pretty good. Now, if you do that twice, like I could do, let's do it right here now. try to go exactly 90 degrees from that. Looks pretty good. Then we go like that. That's my center. Okay. So there you go. Next question is this. Explain the difference between the degree measure of an arc and its arc length. Okay. So let's see. An arc measure. So an arc measure is between 0 degrees and 360 degrees. So it's the arc measure. It's an angle measure based on the central angle. The arc length is proportional to the arc measure and depends on the radius. So the arc length depends on the radius. And it's a distance. There we go. Okay, so let's go ahead and do some of the problems here. Let's see here. So we'll start off with B. Now with B, they're trying to find the arc measure there. And so that's going to be fairly simple because if you just draw in a radius, you know by one of the conjectures that's a right angle. And so B is going to be the same as the measure of the central angle that intercepts the arc. And so B is going to be 180 minus 35 minus 90, which equals 55 degrees. Because the central angle equals its intercepted arc. Okay. And let's see. Number A, looks like we have a cyclic quadrilateral, inscribed quadrilateral. And then we have a inscribed angle that's 110. And so this entire arc right here is going to be 110 times 2, which is 220. Because the inscribed angle is half the measure of its intercepted arc. And that's conjecture 81. And so that's going to mean that 220 minus 155 will equal A. So that's going to make 65 degrees equal to A. Okay, with number 7, so these chords are congruent here. So that's going to make this also equal to C by the chord arcs conjecture, conjecture 77. Call it the chord arcs conjecture. And so that's going to mean that 2C plus 104 will equal 360 degrees. And so let's go ahead and subtract 104 from both sides. Divide by 2. We got 128 degrees. Great. Number 8, let's see. What is E going to be? you know what? This is actually a conjecture that we have not learned. Okay, well, this will not be on the test. But this is, my guess is the textbook got updated and this problem never got removed from it. That's probably what happened. Anyway, it turns out that this angle right here, if we want to call this A, these are both A, right? So A is going to be the average of these two here. So A will be 1/2 times 124. So A will be 62 degrees. And it's called the intersecting chords conjecture. Okay, there we go. But just so you know, that's how you would do it. Okay, D, let's see what D would be. Oh, well, it's a right angle right here, so this should be a diameter. And so 89 plus D will equal 180. So D will equal 91 degrees. Oh, wait, hold on. With A, I didn't finish it, though. Okay, so E is 180 minus 62, which is 118 because of linear pair. There we go. Okay. So 89 plus D equals 180. D equals 91. Then F. Let's see what F is. Okay, F is the same thing, intercepting chords conjecture. So F, number 10, is not going to be on the quiz. You don't have to do it. Your answer is A,